Right, we are now on question number 15. It reads, by sketching two appropriate graphs, show that the equation sine x plus 1 minus 4x squared is equals to 0, where minus 2 pi is less than or equal to x, which is less than or equal to pi, is 2 real roots. So the two graphs must be plotted on the same Cartesian plane, but what you need to do is you need to move 1 and 4x squared to the right side. So you get sine x, right, is equals to minus 4x squared becomes positive 4x squared, then plus 1, it becomes minus 1, something like this. Right, so I'm going to draw the y-axis as well as the x-axis. Then we put 0 as our origin. So we are going to use the given range minus 2 pi to 2 pi. So on this one, I'm going to write pi over 2. Then you write pi. After that, you write 3 pi over 2. Then you write 2 pi. These are critical values. Here, you write minus pi over 2. Then you write minus pi. You write minus 3 pi over 2, as well as minus 2 pi. I hope you are following. So make sure your calculator is in radians. So what is sine minus 2 pi? You get 0. So this is 0, right? How about sine minus 3 pi over 2? You get 1. So if we have minus 3 pi over 2, this is 1. Right, so the graph of sine, it oscillates, right? If it moves to 1, it means the minimum here is minus 1. So the shape that is going to come out is like this. It oscillates like this. I hope you are following. So it means here we have 0, and here we are going to have minus 1. Then sine 0, you get 0. Then sine pi over 2, it gives you 1. Sine pi is 0. Sine 3 pi over 2, it's minus 1. And sine 2 pi is 0. So you get this shape of oscillation. So I'm going to plot my curve like this, like this, like this, like this, like this. So this is the graph of sine theta, right? Then move on to the graph of 4 y is equals to 4 x squared minus 1. So let us identify the intercepts. Right. So when x is 0, y is equals to minus 1. So the first point is 0 and minus 1. Then to find x, when y is 0, you get 0 is equals to 4x squared minus 1, which is 4x squared is equals to 1. X squared is equals to 1/4. Then x is equals to plus or minus square root of 1/4. It means x is equals to plus or minus 1 over 2. So when y is 0, x is half or minus half. So we have another point, half 0 and minus half 0. I hope you are following. Right. So firstly, you need to check pi over 2. Pi divided by 2 is 1,5. 1,5 is a number which is greater than 0,5. So it simply means half is between 0 and pi over 2. So this is where half lies. Same applies, minus half is between 0 and minus pi over 2. So this is where minus half lies. But our graph is passing through 0 and minus 1. 0 and minus 1, this is 0 and minus 1. Right, so we want to connect the points to draw the parabola. So it is going to come out like this. Like this. So this is the graph of y is equals to 4x squared minus 1. So after the sketch, you can clearly notice that our the two graphs are intersecting twice at this point and at this point. So when giving your conclusion, you say, since the two graphs intersect or meet twice, it implies that the equation has two real roots. Then you are home and dry. Let us move on to part B of the question. Right, so number 15, item 2, it reads, verify by calculation that the positive root in 1 lies between x is equals to 0,6 and x is equals to 0,7. So you move everything to one side in such a way that the other side is 0. So sine x plus 1 minus 4x squared now represent what we call f of x. I hope you are following class. So we are saying f of x is equals to sine x plus 1 minus 4x squared, something like this. Right, so we want to prove by calculation that the root lies between x is equals to 0,6 and x is equals to 0,7. So what you need to do is you find f of 0,6, then you find f of 0,7. Sign change. If we have a plus and a negative, it means the root lies between 0,6 and 0,7. So I'm going to substitute sine, open bracket, 0,6, good, plus 1 minus 4, open bracket, 0,6 squared. What do you get? 0,124. So this is plus 0,1246. Then we use sine, open bracket, 0,7 plus 1 minus 4, open bracket, 0,7 squared. You get minus 0,3158. So you write minus 0,3158. So you give your conclusion a sign change implies that the positive root in part A1 lies between 0,6 and 0,7. Then you are home and dry. Let us move on to item 3. Taking x0 is equals to 0,6 as the first approximation. Good. Use Newton-Raphson method twice to find the root correct to 5 decimal places, 4 marks. So you first of all write down the formula for Newton-Raphson. Xn plus 1 is equals to xn minus f of xn over first prime of xn, something like this. So we need to find the derivative of f of x first. So first prime of x is equals to derivative of sine x, you get cos x. Derivative of 1 is 0 since 1 is a constant term. Then derivative of minus 4x squared is going to be found using the power rule. So 2 times minus 4 you get minus 8. Then you less this 2 with 1, you'll be left out with x. So derivative is cos x minus 8x. So since we are given x0 is 0.6, we need to read the question to understand the number of times the examiner wants us to perform the Newton-Raphson. Use Newton-Raphson twice. So if it is twice, it means we need to find x1 and x2. So how do you find x1? To find x1, you substitute the initial value, which is 0.6, in the formula. So we are going to put 0.6 on xn minus, then I put a big bracket, something like this. Then I'm going to substitute 0.6 in f of x to get f of xn. So our f of x, let me put a division line first. Our f of x is sine x plus 1 minus 4x squared. So you write sine 0.6 plus 1 minus 4, open bracket, 0.6 squared, something like this. Then we substitute 0.6 in the first prime to get first prime of xn. So our first prime is cos x minus 8x. So you get cos 0.6 minus 8, open bracket, 0.6. Then you close your bracket. I hope you are following class. Right, so let me punch this in our calculator. So we have 0.6, 0.6, right, minus, then you put open bracket. So this bracket, the first one, is representing this big bracket. Then I'm now placing another open bracket where I'm going to punch the numerator. So sine 0.6 plus 1 minus 4, open bracket, 0.6 squared. Then you close the bracket. We are through with the numerator. Then divide by, then you put another open bracket to punch the denominator. So it's cos 0.6 minus 8, open bracket, 0.6, close bracket. Then you put another close bracket for the big bracket, equals. So they are saying give your answer to 5 decimal places. You get 0.631 3. Then if you round this 5 with 9, you get 6. So 0.6313 6 is x1. So to find x2, you can just use the result on your calculator, then put 31, 36 in front of 6. You just need to play back your calculator like this. In front of this 6, we are going to put 31, 36. So to make it 0.6313, because you are now substituting x1 into the formula. So what you need to do is you make sure that you place this arrow in front of 6, then you write 31, 36, then you move on. In front of 6, you place this arrow, then you punch 31, 36, then you move on. In front of this 6, you put this arrow, then you punch 31, 36, then you move on. In front of this 6, you put this arrow, you write 31, 36. Then lastly, you write 31, 36 again. Then you put equal sign. You get 0.63037. So 0.63037. And this is your final answer, since they want you to perform it twice. Right, so sometimes they may be silent on the number of times that you perform. So you keep on punching until the decimal places start to decay.